In any group, you can define something that is called the center of the group. And the center of the group is just the set of all elements of the group that commute with every other element of the group. Okay? The center of the group is never empty because the identity is in the center. Because the identity commutes with every other element of the group, right? If you have an element G and you multiply by E, then you get E times G. It's the same thing. Both of them are equal to G, right? So this is one of the elements that belongs to the center, and so we know that the center is never empty, right? What we're going to prove now is that the center is a normal subgroup, and for that we're going to prove that it's a subgroup, right? Because the fact that it's normal, remember normal subgroup means it is a normal subgroup if the left cosets are equal to the right cosets, but that's automatic in the case of the center, because in the center all the elements in the center commute with any other element, in particular with the element that you put here. So these two cosets are the same, of course. So all we have to prove in this exercise is that the center is a subgroup of G, right? And for that we're going to use the characterization of groups. So we're going to take two elements, x and y, that belong to the center, right? Okay, and using just this property, the fact that they belong to the center and therefore commute with every other element, it's going to be sufficient to prove that that the product, this product, also belongs to the center, right? Okay, so that's what we need to prove. And in order to prove this, what we have to prove is that this commutes with every element of the set, right? In other words, if we take G, right, which is an arbitrary element of the group, okay, and then we left multiply this by this element, x times y negative 1, right? We have to prove that this is equal to x times y minus 1 times g. So we have to prove that this. All right, so let's see how to do that, okay? And for that, one strategy is we start off from here, right? So we begin with this product. Well, let me just omit this asterisk and write this way, okay? All right, now we apply the associative property, so this is equal to this, okay? Product of these two times this one, right? And since x is an element of the center, it commutes with G, so we can write this just like that, okay? Y minus 1. And now we associate again this like this. This is equal to, sorry, x equal x times G y minus 1, right? And, well, you know, the product a b minus 1 is equal to b minus 1 a minus 1. So we do this here, and then we can rewrite this expression like this as y times g minus 1 minus 1, right? Because if you do this, this is the product of these two inverse in reverse, which means the inverse of g, which is g, and the inverse of y, which is y minus 1, right? So this can be written like this. All right, so g minus 1 is an element of the group because g is an element of the group, so it commutes with y because y is an element of the center. So we can rewrite this like this, g minus 1 times y minus 1. And then we apply this property again, and we rewrite this as the inverse of y times the inverse of g minus 1, which is just g. And once again we apply the associative property, and then we end up with this. So we have proven this property here, right? G times this element is equal to this element times g, which means that x times y minus 1 belongs to the center, and therefore the center is a subgroup of the group G. And because the center is the set of all the elements that commute with every other element, the left and right cosets are both the same, and therefore the subgroup is normal.